Hi everyone, and welcome back to the sampling lectures. In these last two videos, I want to go through the different sampling methods. In this video, I want to explore those methods that employ random sampling, and then the next video, we're going to talk about common non-random sampling methods. Remember that random selection was a key point to helping increase the representativeness of the sample, which then allows the research findings to be generalized from the sample to the population, and it gives the study external validity. Any method of sampling that uses random selection is known as a probability sampling method. Now, there is an important part of random selection, and that is known as EPSM, or the equal probability of selection method. EPSM means that every person in the population, no matter who or what they are, has an equal chance of being chosen to participate in your research study. And this is really important because it's a really common misunderstanding about random selection. People think random selection is just randomly pointing to different people and saying, you'll be in my study, you'll be in my study, you'll be in my study, right? But random selection in sampling is so much more. First, in order to ensure that every person has an opportunity to be in your study, you have to start with a list of every person in your population. This list is what we call a sampling frame. It's a starting point for any probability sampling method. If you cannot get a list of everyone in your population, then you will have to do a non-probability method, which we'll discuss in the next video. There are 5 major probability sampling methods that are described in your textbook. I'm going to go through the first 3 with you. Cluster and multi-stage sampling are very important, and they're very common methods of sampling, but they're also much more complex than the first 3. And as such, I think that they're more appropriate to a more advanced methodology course. In my course, you're only going to be responsible for learning and applying the first 3 types of probability sampling. So let's start with simple random sampling. In simple random sampling, it's an easy 2-step process. First, you assign a unique number to everyone in your sampling frame. Then, you randomly pick numbers in some method, and you identify which participants those numbers represent. Typically, researchers use random number generators or lists of randomized numbers to choose the final sample. There is also the quintessential version of simple random sampling, and that's to throw everyone's number into a hat and then pick out the number of people you need for your sample. The best part of simple random sampling is that it is super easy to do once you have the sampling frame. The problem is the construction of the sampling frame. Remember, you have to know the entire population in order to assign everyone a unique number, and that can be very challenging if you're working with a population that contains hidden or transient persons. Assigning everyone a unique number can also be time-consuming, particularly if you're doing so manually. You'll get a chance to see what I mean in this week's activity, but don't worry, I didn't make your sampling frame too big. Systematic sampling works very similarly, starting with a sampling frame where every element in the sampling frame is given a unique number. Instead of randomly picking numbers, though, systematic sampling uses a selection process where you pick every kth person. K stands for the sampling interval, and it can be any number. It's a letter that stands for a number of your choice. The way to calculate K is to take the total number of people in your population and divide by the sample size that you want to create. In this example, you have 9 people in your population. If you want to get a sample of 3 people, you take 9 and divide by 3. That leaves us with a K of 3. Once you have calculated your sampling interval, or your K, then you're going to go through and you're going to pick every kth person. In this case, I would pick person 3, person 6, and person 9. Now, the biggest concern with systematic sampling is the impact that patterns in your data set will have on your final sample. Let's say that every other person in my sampling frame was a boy. So everyone with an even number would be a boy, everyone with an odd number would be a girl, right? That means that a K of 3 would exclude all of the boys in the sample, and a K of an even number would exclude all of the girls in the sample. So we want to make sure that our sampling frame doesn't have any organizational patterns or structures before we use a systematic approach. Stratified sampling is a way to get at more complex topics. Stratified sampling is a 2-stage process. In the first stage, you create multiple sampling frames, and these are called strata. The sampling frames will consist of all of the elements in your population that are grouped by whatever characteristic in your population that you're trying to study. In stage 2, you will use either simple random sampling or systematic sampling to select elements from each strata. All of these elements together will be your final sample. So let's say you want to know what experience customers had at a new ice cream store in town. One way to go about this is to use simple random sampling or systematic sampling to get a random sample of customers and ask about their experiences. So I gather up a list of the first day's customers. There were 15 people in total, and here were their reactions to the new store. Well, then I decide that I want to explore their experiences more fully, right? I want to pick 3 people to go talk about their experiences more in depth. I still want to randomly sample from this population, but I also want to make sure that I hear from people who really liked the ice cream store, people who were neutral, and people who absolutely hated the new ice cream store. That way, I can make sure I get a full range of experience with the store before I make my conclusions. To do this, I'm going to sort all of the first day customers into 3 strata based on their feelings towards the ice cream store. So I create 3 different groups, 1 for each attitude towards the store. Then I'm going to use either simple random sampling or systematic sampling to select 1 person from each group. So first, I'm going to number everybody with a unique number, and then I'm going to randomly select 1 person from each group. Now that my numbering scheme, notice that my numbering scheme starts over for each strata. That's because I'm going to treat each strata as its own population. I'm going to use a random number generator to choose a random number. Since each of my strata is differently sized, I need to draw a different random number for each strata to make sure that all the people in the strata have the ability to be chosen for the final sample. My random number generator gives me 2 for my first strata, so I select participant number 2. My random number generator gives me a 5 for the second strata, so I grab participant 5 from the happy strata. And my final random number is 1, so I select participant number 1 from the unhappy strata. I take out all of those customers that were not selected, and that is going to leave me with the final sample of 3 people that represent all 3 attitudes that I noted in my initial survey, and still done randomly, right? The advantage of stratified sampling is that it can allow us to gather a more representative sample than what can be attained from simple random sampling, because you can make sure that you include all of the important groups within your population. The problem with this type of sampling is that you have to be able to put each element into a single strata only, and that can be difficult depending on the characteristics being studied. For example, if you're interested in stratifying by both race and gender, you will need to create a separate you will need to separate each racial group into each gender identity, which can make stratified sampling very complex, and it may require a much larger sample than traditional simple random or systematic sampling would. All right, well, that concludes our discussion about common probability sampling methods. Next lecture, we're going to talk about the non-probability methods that are covered in your textbook.